Okay, we're recording now. And let me get the screen share set up. Okay, so here we are. I don't think I'm going to say that much about the test since I've given you everything you need for the test. You should have gotten an email back from me about your score on the exam. Some quick reminders of the test. So the style of the test is like all of them. So if you like this test, you'll like all of my tests. If you didn't like this test, you're not going to like any of my tests because they're all like this. All the questions were very similar to what you saw. There weren't any trick questions, there weren't any surprise questions. I tend to give about 10 questions, something like that. I think I gave you 11 questions. Okay, so it ended up being one question was extra credit. So if you got over, it's possible to get over 100. If you got over 100, you got 100. You shouldn't really complain about that. Okay, so that raised a lot of people's grades, I think it was. Okay, and there was that requirement for the homework. So if you did not submit your homework, I didn't grade your test, it counts as a 0. That's a requirement. You have to show me the homework in order for me to count your test. Okay, so that's what happened with that. All right, so it looks like the next test is going to be Thursday the 25th. Okay, and reminder, we have some holidays coming up. Friday, well, we don't meet on Friday anyway, but it's a CSM holiday. Friday and Monday, we do have a 4-day weekend. So in case you have other classes at CSM on Friday and Monday, we have a nice 4-day weekend. So that's that. But that does mean that I have to go a little bit faster for some of this stuff. So we'll see how it goes. Okay. All right. So, and you have the video. I made a video on the exam. So if you want to compare how you did with the questions on the test, you can just check the video for that. Okay, it was 10 points per question, and I emailed you back your score on each of the questions and your overall grade. Okay, and my grading scale again is 90, 80, 70, 60. So 90 is an A, 80 is a B, 70 is a C, 60 is a C, 60 is a D, and less than 60 is failing. And if you're quote unquote close, that's where the plus or minus grades come in. So 90 is an A, so 89 you're off by 1, so that might be an A minus, and 88 might be a B plus, and so on down the line. Okay. All right, so that's the way that worked. Quickly check the chat. Yeah, I think we're good. Okay, so we'll go ahead and get started with where we are. Okay, so we're on to the next section. I'm changing the homework a little bit. Sorry, I'm giving you a little bit more. The original was 5 and 6, I believe it was. It's now 3 through 6. 3, 4, 5, and 6. It's not really that bad. And I'll do all the evens, hopefully, and at least one of each other type. Okay, so on schedule is 3.3 and some of 3.4. Again, in reality, I'm ahead. If I keep the schedule, I'm really ahead because we have 2 weeks at the end for buffer in case something goes wrong and so forth. Okay. All right, so let me jump to 3.3 and go right to this. A lot of it is domain and range and some more new language that we shall see. Okay, so 3.3, so we're doing shapes of graphs and average rate of change. Average rate of change is really just slope. Okay, if you want to think of it as slope of the line joining 2 points, that's basically what it is. Okay, so maybe I'll just write in my book. I know I'm not selling my book, so if you want to just put this down also. Average rate of change really is just a slope. All right, so on page 154, okay, you're going to be getting a lot more of this when you get to calculus. We're in pre-calculus now. But we will use language like the function is increasing or decreasing. Okay? As I move from left to right, okay, here we would say the function is increasing, then increasing, decreasing, going up, down, up, down. Just think of a ride, like a roller coaster ride, okay, as I'm moving from left to right. If I'm on this ride, I'm going up. Then I'm going down, then I'm going up, and I'm going down. Okay. And some other terms that I think are fairly obvious. Maximum value, minimum value, a high point or a low point. So that looks like a maximum value, right? That looks like a minimum value, maximum value, minimum value. So a high point or a low point. Okay. So if you're on a roller coaster, as you know, this is a maximum point, right? It starts to turn down. This is a minimum point. It goes down and it goes back up, right? Okay, so we'll use that kind of language here. Okay, so here we go. So on page 162, and again, I'll project it for the benefit of those of you that don't have the book and aren't planning on getting it. So page 162. So it's now 3 through 6. Originally it's 5 to 6, 3 through 6. So let me show you questions. There's 3, there's 4. Oops, I don't think I showed you 5. There's 5 and 6. Okay. And then let's see, 9 through 16 all. So 9 through 16, there's 9 average rate of change. There's 15 and 16. Oops, let me show you all of 16. 16A, and there's 16B and C, I guess. All right, then what else are we supposed to do here? 23, 25, and 29. So yeah, 23 and 25 and 29. And there we go. Okay, so let's try to knock off as much as we can. And for some of these, sorry, I'm not going to be able to write it because, again, I have to show you the book. And if we were meeting on campus, I would project this on the screen and write some of the answers on the whiteboard. That isn't happening here. So, sorry, you just have to write some of the answers as I say it. I won't be able to write it because I'm showing you the book. So try to keep up with writing the answers for these. Okay, so on these graphs, give the range of the function. The domain is from 0 to 4, bracket 0, 4. Give the range, maximum, minimum, intervals of function increasing, intervals where the function is decreasing. Or maybe I can just write it directly in my book. We'll see how it goes. Okay, so 4. I think I'll just write it in. Okay, so what's the range? Range is the extent of y. So y looks like it goes from -2 to 2. Okay, so yeah, maybe I'll just write it in my book. So the answer to A is bracket -2, 2. B, maximum value and minimum value. Okay, so the maximum value is 2 and the minimum value is -2, right? So max 2 and minimum -2. I'll abbreviate maximum with max and minimum with min. Okay, and that kind of makes sense because that was the range anyway. So this is the highest and that's the lowest. So the maximum value, that's B, and C is the minimum value. Okay. Then intervals of increase and decrease. Okay, so where's the graph going up? Where's the graph going down? Okay, so where is it increasing? If I want a roller coaster, always going from left to right. We're never going to go from right to left. Always going from right to left. We're increasing from here to here. So let's look at from 2 to 4. Open interval from 2 to 4. Strictly speaking, right at 2, you're neither increasing nor decreasing. And likewise, right at 4, you're not increasing or decreasing. So open interval 2 to 4. And then E, intervals where the function is decreasing. So where's the graph going down? Well, it looks like it's going down from here to here. That's from 0 to 2. Okay, X coordinate. As X goes from 0 to 2, the graph is decreasing. Okay, raise it up a little bit for focusing purposes. And there's the questions again. Okay. All right, 6. Same question. Give the range. This kind of looks like it's part of a trig function. It's still -2 to 2. So let's see, I'll put it over here. Including -2 and +2. Maximum and minimum, same thing. The maximum is 2. The minimum is -2. And then intervals of increase and decrease. Where is this graph increasing? So if you're on this roller coaster ride, you're going up. Well, you're going up from here to here. Then you're going down. Then you're going up from here to here. Then you're going down again. Okay, so increasing. The X coordinates are 0 to 1, so 0, 1, union 2 to 3. That's where I'm going up. If I was on this roller coaster ride, you would say I'm going up from here to here, and I'm also going up from here to here, and then I'm going down here to here, and here to here. That's part E, right? So intervals where the function's decreasing. So 1, 2, right? From here to here, you're going down, and also from here to here, which looks like 3 to 4. So there we go. So hopefully that's not that big a deal. Okay, so I did the two even ones, 4 and 6, and you do 3 and 5 in a similar fashion. Okay. So that takes care of that. Okay, 9 through 16 all. Average rate of change. Okay, the average rate of change is just the slope of the line joining the 2 points. Okay, they give you the x coordinates. They tell you an interval. You have to come up with the y coordinates. Okay, so I'll show you how to do that. Okay, so this is page 163. Page 163, number 10. Section 3.3. So they say f of x equals radical x on the interval from 4 to 9. So they ask for the average rate of change. It's just a slope. In fact, if you want to put that in your next formula sheet, your next cheat sheet, you may. Okay. These are both x values. How do I get the y? Plug into the function. Remember when it says f of x, that means y. So 4 comma square root of 4, 2. 9 comma square root of 9, 3. And I do the slope. So y2 minus y1, 3 minus 2, divided by 9 minus 4, which is 1/5. Okay, that's all there is to it. Okay, so average rate of change of a function is just a slope. They give you the x coordinates, plug in to find the y's, and then go from there. Okay. Number 12, please. X cubed minus x from 1 to 2. One to 2. These are both x values. So first you have to find the y values. So plug in 1. 1 minus 1 is 0. Plug in 2. 2 cubed is 8. Minus 2 is 6. Right? Find the slope. So y2 minus y1, 6 minus 0, divided by 2 minus 1. So that's 6 divided by 1, or just 6. Okay. That's all. So you just, these are x values, plug in to find the y values. 14, h of t is 16 minus 7t. And they give you a real bad interval. 14 rather. Negative radical 2 to 2 radical 2. That's a mean trick. Whoops, negative radical 2, 2 radical 2. Well, h of negative 2 is 16. Okay, let's see. If I plug in a negative 2, I have a double negative, right? So plus 7 radical 2. And h of 2 radical 2. Oops, I forgot to put the square root there. H of negative square root of 2. H of 2 radical 2. Put a 2 radical 2 there. 7 times 2 is 14. 16 minus 14 radical 2. Very clumsy, as you can see. Paper's curling up on me again. Okay, so you plug in negative radical 2, 16 minus 7 times a negative radical 2, that's double negative. plug in 2 radical 2, I get this. Okay. So I get a messy slope. So it's this minus this. 16 minus 14 radical 2 minus parentheses 16 plus 7 radical 2 over x2 minus x1. That minus that. 2 radical 2 minus a negative radical 2. Now, that looks pretty bad, but take a look at what happens. If I distribute this minus, that 16 and that 16 cancel out. Do you agree? In other words, I can just go like this. It'll be 16 minus 16. And then I'll be left with a negative 14 radical 2 minus 7 radical 2. That's a negative 21 radical 2. And this is double negative. 2 radical 2 plus, right? Making both pluses. So 2 radical 2 plus radical 2 is 3 radical 2. Radical 2's cancel out, and negative 21 divided by 3 is just negative 7. So it looks like the answer is just negative 7. Okay. All right, then let's see. 16 is the next one. I do see something in the chat, so let me get that quickly also. 16, this time they draw the function by plotting points, right? So they go 8, 16, 24, 32 on t, which is days. And horizontally, they got f of t in grams, I guess. So they got 1/2, 1/4, 1/8, 1/16. Okay. And this is iodine 131. And sample decays over a 32-day period and so on. Okay. So we're doing delta F over delta ET, that triangle, still means change in F divided by change in T. Okay, so delta F divided by delta T, change in F divided by change in T. It's still a slope. So we're doing the same thing as we did before. Only difference is they don't give you a rule for the function, they give you the graph. Okay, so we base everything off the graph. Okay, and let's see, let me go ahead and check the chat. Can you put the max as ordered pairs? Yes, so 0, 2, 4, 2. Yeah, that would be fine. Retake exams, there are no retaking of exams, but you get to drop an exam. Okay, so that sort of makes up for it. Okay, so that is how that works. Okay, let me try to uncurl the paper again. Okay, so they want you to go from 0 to 8, 8 to 16, 16 to 24, 24 to 32. Okay, so let me write that down. 0, 8, 8, 16, 16, 24, 24, 32. If you're doing exactly what I'm doing, leave a little gap here, leave a space to write some stuff. Okay, now I would just read off the graph. Okay, so it's 0, 1, 8, 1/2, 16, 1/4, 24, 1/8, 32, 1/16, and so on. Okay, I'm just getting this off the graph. So 0, 1, 8, 1/2, 8, 1/2, 16, 1/4, 16, 1/4, 32, 1/8. Oops, 24. 24/1/8. That's 24. All right. 24/1/8. 32/116. Now, where am I getting these points from? Right off the graph. 0, 1, 8, 1/2, 16, 1/4, 24/1/8, 32/116. Okay. So they told me to go from 0 to 8. Those are like the x values. The y values I just read off the graph. And just find all the slopes. So delta f over delta t, change in f divided by change in t. Actually, all of these change in t's are 8, right? That's 8, that's 8, that's 8, that's 8. So you know the denominator is going to be 8. Okay, I guess formally 8 minus nothing. And this is 1/2 minus 1, which is negative 1/2 divided by 8, which is negative 1 over 16. And that would be grams per day. The units of the function are grams. Grams of iodine 131. And the units horizontally are days. So we're losing 1/16 of a gram per day. Okay, then do the same thing here. So this slope is 1/4 minus 1/2 divided by 16 minus 8. I already know my delta t, my change in t is 8. So 1/4 minus 1/2 is negative 1/4. So that comes out to be negative 1 over 32 grams per day. So in other words, the amount of radioactivity is less as time goes by. And do the same thing here. Average rate of change. Even though I'm writing m, it's average rate of change. Okay, but it's a lot easier to write m than to keep writing AVG, right? Okay, so this one is 1/8 minus 1/4 divided by 24 minus 16. Let me raise it up again. See that? This is negative 1/8 divided by 8, which is negative 1 over 64 grams per day. And finally, the last one, the slope is y2 minus y1, 1/16 minus 1/8 divided by 32 minus 24. And 32 minus 24, of course, is 8. 1/16 minus 1/8 is a negative 1/16. Negative 1/16 divided by 8 is negative 1 over 128 gram per day. Okay, in case you're wondering how to do this fairly quickly, I'll just put this for this one. You can get the same idea for these. Remember that if you divide by 8, it's the same as multiplying by 1/8. One way to think of it, right? You're dividing by 8, which is 8 over 1. So you multiply by 1 over 8. That's where I get the 128. Same logic for all the other ones there. Okay. B, find the average of the 4 answers in part A. Find the average. Average means add them up and divide by 4. So here we go. Negative 1/16 plus negative 1 over 32 plus negative 1 over 64 plus negative 1 over 128 divided by 4. Divided by 4 means multiply by 1/4. Okay, change all of these so they have a common denominator of 128. Okay, that's negative 1. This is negative 2, this is negative 4, and this is negative 8. Okay, multiply that by 8 over 8, 4 over 4, 2 over 2, 1 over 1. So this is going to be what? 512, 4 times 128, 512. You can punch it in your calculator. And that comes out to be negative 15. Grams per day. And then part C. Compute delta f over delta t over the interval from 0 to 32. So pretend we're going from 0 to 32. So I use this point, 0, 1, and 32, comma 116. Okay. So slope is 1/16 minus 1 divided by 32 minus 0. This is negative 15 over 16 divided by 32, which comes out to be negative 15 over 512 grams per day. And they just ask you to check, is it the same as the answer you got over here? The answer is yes. They turn out to be equal. That's all it asks. Okay. So I think I've done all the evens for you here. So we have 23, 25, and 29 left. So let's see what that's about. 23. That f of x equals x squared. And they're asking you for all this other crazy stuff here. Okay. So I'll do B, since it looks a little harder than A, just to set you up. You're going to see this expression quite a bit when you get to calculus. We're in pre-calculus now, but behind the scenes, you may not know it, but I'm kind of chuckling here when I see f of x plus h minus f of x all over h. You will see that expression when you get to calculus quite a bit. So they're setting you up for that. And sort of the same thing over here too. Because how about do 23b? Okay, and I'll let you do A on your own. 23b, whoops, I don't want that to be in red. The function is x squared. And they want f of x plus h minus f of x all over h. Okay, f of x plus h means you square x plus h. Minus the original function squared, x squared divided by h. Okay, so how about I multiply that stuff out? X squared plus 2xh plus h squared. That's x plus h times itself. X plus h times x plus h. Minus x squared all over h. And notice that these two cancel out. Right? And then what's a common factor here? H. And that h is going to cancel h in the bottom. So factor out the h. 2x plus h, and then these two cancel out. So my final answer is 2x plus h, like that. Okay. Okay, then let's see, we have 25 and 29. Something similar. So 25, 29 looks harder. So how about I do 29? And then it looks like we're done with the section. Okay, find the difference quotient, f of x minus f of a divided by x minus a. And there's that f of x plus h minus f of x all over h stuff again. Okay, difference quotient. I don't think you have to write that on your formula sheet, but difference quotient. Difference means what operation? Subtraction. Minus, minus. What's quotient mean? Divide, divide, divide. So there it is. Okay, so 29 is f of x is 1 over x. Okay, so part A, they say f of what? Where'd it go? F of x minus f of a divided by x minus a. Well, f of x is 1 over x. F of a is 1 over a divided by x minus a. Okay, technically that's correct, but not really. You don't want to leave it like that. the way to clean it up is to multiply numerator and denominator by ax, which is the common denominator for these two guys here. Okay. So distribute on the top. Don't distribute the bottom. It turns out to be better not to, and you'll see why in just a moment. Okay, so 1 over x times ax. The x cancels out, right? So you have a minus 1 over a times ax. The a's cancel out, and you have x. Okay, so right now I have this. And now, do you remember anything like this from algebra? A minus x divided by x minus a. Okay, it's not 1. It's actually negative 1. Anytime you see something like this, that's a negative 1. So the final answer is negative 1 over ax. Okay, so this problem's finished. Let me dig a little deeper. So in general, anytime you see a minus b divided by b minus a, did you learn this in algebra? It's always negative 1. As long as a and b are different. If a and b are equal, you're subtracting each other, so you get 0, which means you can't do it. But let's just plug in, how about 3 and 10? What's 3 minus 10? Negative 7. What's 10 minus 3? Positive 7. So when you divide, you get negative 1. It always works. How about, let's say, I don't know, 4 and 2? What's 4 minus 2? 2. What's 2 minus 4? Negative 2. So what happens when you divide them? Negative 1. Okay. So this thing here is always negative 1. If you want to put this on your cheat sheet, you may, in case you forget that. Okay. Okay, then part B, then I'm done with a section actually. So they once again ask for this funny thing, f of x plus h minus f of x all over h. So the original function is 1 over x, so it's 1 over whatever. So 1 over x plus h minus 1 over x all over h. Okay. That does not look very nice at all. So how do I make it look nicer? Okay, first, recall if you divide by h, remember it's like h over 1, you multiply by 1 over h. Right? So dividing by h is the same as multiplying by 1 over h. We know that. That's like saying if you divide by 7, you multiply by 1/7. Right? Then I have this stuff. 1 over x plus h, leave a space, minus 1 over x, leave a space. Okay, so there's all that. And dividing by h, multiply by 1 over h. And now I have this. Can you guess what I'm going to put over here and over here? Right? I need to have a common denominator. So this side needs that, and that side needs this. Think back to arithmetic, right? When in arithmetic, you had 1/3 minus 1/5, right? Then the 5 needs a 3, and the 3 needs a 5, right? Whatever's on this side, you put on the other side. Okay, so this side needs x over x, and this side needs x plus h over x plus h, right? So now we have a common denominator. So common denominator is x times x plus h. And now what's on top? X minus, now that minus is in parentheses, it's minus each of these, so each of these becomes negative. X minus h, like that. And what do you notice in the numerator? X minus x cancels out. You have a negative h, positive h. Cancel, cancel. So you're left with negative 1 on top. So final answer is negative 1 over x times x plus h. And by the way, you could leave it like that. It's not wrong if you multiply it. I'll let you multiply it out, but you know, no need to. That's going to be fine. All right, I'm actually done with 3.3. It's not even noon yet, so I'll keep going a little while, and just save me some time for 3.4 later. Okay, so let me get started with 3.4. There's a lot of stuff in 3.4. Pretty heavy topics here, so I'm glad to knock off 3.3 right away. So what's 3.4 all about? Okay, so let me get started with 3.4, please. Topic is techniques in graphing. Sometimes these are called translations. Translation means to move a graph. Okay. Now, in ordinary English, we think of the word translation like you translate a language, right? Okay. But you can look it up in a dictionary. There's an English definition of translation, which means to just move an object, move it up, down, left, or right. Okay. That's another definition of translation. Okay. So we're going to have vertical translations. I'll show you the next page, but can you guess if we have vertical translations, what else do you think we might have? Horizontal translations. And yeah, you definitely may want to put these on your next formula sheet, next cheat sheet. As my stack of papers fell down. So let me show you an example. So where am I? Page 167, figure 2. Okay, I'll raise it up right now, but I have to put it back down because the book's heavy. But absolute value function. The black one is absolute value. Okay. Look at what happens to the red one. Absolute value of x plus 2. Well, you just move 2 units up. Blue one, absolute value of x minus 2. You just go down 2 units. See that? Okay, so the black one in the middle is absolute value of x. Then the red one is absolute value of x plus 2. Sorry, I can't really hold it. Plus 2, and this one is minus 2. Okay, so that's a vertical translation. A vertical translation. Now, I don't think you have to write all of this stuff down. In fact, it might even be better if you just put an example like this. Okay, so if you see a function, right? And it says blah, 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 plus 7, just go up 7. And if it says blah, 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 minus 8, just subtract 8. Okay? Now, there's nothing wrong with all this, but it's quite wordy. It's absolutely correct, but you want to put something fast on your cheat sheet, right, on your formula sheet. So for vertical translation, okay, maybe you just say here, okay, y plus c, then you go up. Y or f of x, remember y is like f of x minus c, then you go down. That's called a vertical translation. Okay. How do you get a horizontal translation? So next page, 168. So look at these 3 graphs. I'll raise it up a little bit. The one in the middle, the black one, is y equals x squared. Then they have, notice how they write x plus 5 squared. The plus 5 is in parentheses. Now, the previous one we did, the translation thing was outside of the function. It was like off to the side. But now the plus 5 is inside the parentheses. So x plus 5 squared got moved 5 to the left. And the blue one, x minus 5 squared, got moved 5 to the right. Okay. And again, if you want to put these as examples, you may. I'll hasten to add, this is actually counterintuitive. This one, vertical translations, that's kind of intuitive, right? You say, okay, plus 2, oh, go up 2, down 2, go down 2, right? But this kind of goes against your intuition, right? Now, my first guess would have been plus 5, right? It's, oh, plus 5, you go to the right. No, you actually end up going to the left. So it's against your intuition. And similarly, right, when you see x minus 5, so my first guess would have been, oh, move 5 to the left, but it isn't, you move 5 to the right. Okay, and what bears that out is if you try some of these points. Okay, this is 0, 0, right? When you plug in 0, you get 0. Let's take a look at this. X plus 5 squared, right? What do you get when you plug in negative 5? What's negative 5 plus 5? 0. square it, you get 0. So that works. But notice if you plug in a positive 5, okay, positive 5 for this one, 5 minus 5 is 0, 0 squared is 0. You have the 0.50, okay? So it goes like so. So this is kind of against your intuition for horizontal translations. Okay, so if you can look right here, f of x plus c, shift to the left c units. F parentheses x minus c, that shifts to the right c units. Okay. Again, you don't probably want to write that whole paragraph down. Maybe cut it down, or maybe just show some examples of what happens here. Okay. Now, there's a combination of these. Okay, so they combine all of these. Y equals x squared. You should know y equals x squared is our famous parabola, right? So how about parentheses x minus 2 squared plus 1? Okay, so there's two things going on. There's a vertical and a horizontal translation. Okay, parentheses x minus 2. That's 2 units to the right. That's like this example here. Okay. And what about that plus 1? 1 unit up. Okay. So look at figure A, y equals x squared. B, x minus 2 squared, 2 to the right. And then C, go up 1. So y equals x minus 2 squared plus 1. So from here, 0, 0, right? 0, 0 becomes 2, 1. By the way, double check. Look at this last one. What do you get when you plug in 2? 2 minus 2 is 0. 0 squared is 0 plus 1 is 1. So it works. It definitely works. You do get the point 2, 1. Okay. Okay, now we have some reflections. Page 169. Let's take our famous parabola, y equals x squared. Do you remember what happens with negative x squared? Negative x squared, it went down, right? A way of saying that is that you got a reflection across the x-axis. If you kind of put a mirror here, the mirror image would end up going down like so. So figure 5, the starting function, the black function there is y equals square root of x. Okay. You got 1, 1. Now, if I put a minus sign in front of it, well, 1, 1 will become 1, negative 1, right? If I plug in 4, I will get 2. Put a minus in front of it, it'd be negative 2. So it reflects down here. So the blue graph is y equals negative square root of x. See what happens? So you have the reflection of the graph across the x-axis. Pretend you have a mirror here. The mirror image of the black function is the blue function. Okay. Now, what if the negative is inside the radical? So look at this one. Square root of x. Square root of negative x. Notice if you plug in 1 here, you get 1. If you plug in negative 1 here, you'd have the opposite of negative 1, which is positive 1. Okay. That looks like a reflection across the y-axis. Okay. So we have this rule here. Where is it? Page 169. Reflections in the x and y axes. Okay, so let f be a function replacing y by negative y in the equation gives a new equation, negative y equals f of x or y equals negative f of x, whose graph is that of f of x reflected in the x-axis. That's quite wordy. Let me just tell you what you really need. Okay, if you have the original graph f of x, negative f of x reflects in the x-axis. If you have f of negative x, like that, reflect in the y-axis. Okay. So this one, square root of x, the negative is outside the radical. negative square root of x, reflect across the x-axis. Square root of negative x, that's f of negative x, that's a reflection in the y-axis. There's a lot here, I know, it's a lot. Put it on your formula sheet, put it on your cheat sheet if you wish for these. Okay. All right, it's almost 12. I think it's a good time to break. So we'll break now. Okay, so let's see. I don't see anything else in the chat, so we'll stop the share. I have 11:57, so let's start up at 12:10. Okay, so start up again at 12:10, please. I'll put that on the chat also. Okay, so we'll break until 12:10, and I will disappear also. Okay, folks, let's pick up where we were. It's 10 after. So we'll go on. Okay, so schedule-wise, I'm done with 3.3, and I'm doing some more of 3.4. So I'll do some more of 3.4, then maybe give you something to do in class involving this. Okay. So let's pick up where we were. So a quick mini review of where we were. We had vertical translations, page 167. So again, the black graph in the middle, absolute value of x. The red one, absolute value of x plus 2. Write it like that. Absolute value of x minus 2. The blue one, you go down 2. Again, I highly advise you to put stuff like this on your next formula sheet, your next cheat sheet. Okay, y equals x squared. This is page 168. Parentheses, x plus 5 squared moves 5 to the left. That's against your intuition, perhaps. Okay, the plus 5, you might think it goes to the right, but it doesn't go to the left. And the blue one, x minus 5 squared, moves to the right 5 units. Then we have the reflections. So square root of x, negative square root of x, reflects across the x-axis. Square root of negative x, reflect across the y-axis. Okay, so that's where we were. Next thing I want to talk about is vertical scale changes. We're going to see a lot of this when we get to trig. Okay, I know a lot of you have varying abilities in trig. Some of you have had trig, some of you haven't. I'll survey you a little bit later, but we'll get this also. Okay. Suppose I have a coefficient in front of the original function, f of x. So suppose I put a 2 in front or a half in front, but that's either going to stretch it or compress it. The language that we say is that we have vertical compressions or vertical stretches. Okay. You either stretch it out or you kind of make it smaller, compression. Sometimes you hear the word shrink. It ends up being shrunk. Okay, and I'll show you what I mean. Some examples. Let me take our familiar y equals x squared. Here's 1, 1. Okay. Suppose I have y equals 2x squared. Okay, so what happens when I plug in 1? 1 times 2 is 2, so that would go higher here. When I plug in 0, I still have 0. Okay. So it's going to be kind of like this. It's a vertical stretch. Okay. So we will sometimes use the word stretch right here. Y equals 2x squared. On the other hand, suppose I have y equals 1/2 x squared. 1/2 x squared. But when I plug in 0, I still have 0. But when I plug in 1, I get a half. That's lower. So that's going to end up going like this. So sometimes we call that a compression. Okay, I should make this a little bit bigger to match what's going on here. Yeah. Okay, so the blue one's the original graph. Kind of botch it up there. Okay, a vertical stretch multiplied by 2. Right? So it's as if you take the parabola and just kind of stretch it out that way. Then if I multiply by a number that's smaller than 1, like a half, it shrinks it or compresses. And so the language that's sometimes used is shrink or compresses. It's as if I took the parabola and kind of pushed down on it to make it closer to the x-axis. Okay. And you'll see a lot more of that when we get to trig. So x squared, 2x squared stretches out, half x squared compresses it. Okay. Vertical scale change. Okay. If you don't understand what all this is about, okay, it's probably better just to think of an example. Okay. In my opinion, the example that I have here is probably good enough for what you need. Okay. And now a horizontal scale change. What does that mean? Horizontal scale change. We're going to see a lot of that when we get to trig also. But let me try if I can show it to you like this. This is a vertical stretch. Vertical stretch change. Now let me do a horizontal stretch change. Let me start off with our basic y equals x squared again. Okay, instead of having a coefficient, how about inside the parentheses, we have the change. Okay, so what do you mean by that? So how about this one? Y equals parentheses 2x squared. Well, we know that's the same as 4x squared. That's going to end up going like this. And likewise, suppose I have y equals half x in parentheses squared, which is the same as 1/4 x squared. But we know from before that's going to go lower. Okay. This is going to be considered a horizontal compression, okay, which is weird because even though we said it's a stretch here, but if you look only in this direction, it's like you take the parabola like this and you squish it in. Okay, so that's considered a horizontal compression. Horizontal compression. And this is the opposite. Take the parabola and make it come out wider. So it ends up going like that. That's considered a horizontal stretch. Now, it seems kind of contradictory because you might look at it and say, well, it's the same kind of graph. Right? In one case, it's a compression, and yet in the same moment, you're saying it's the opposite. It's a compression, and actually it is, because take the blue graph. Vertical. If I look at the green, it's like you take the graph and you scrunch it down. But imagine I take these two like pins and move it up, then it goes like this. So vertically, it's a stretch. But horizontally, it's the opposite. Okay? Take the original parabola. Horizontally, this way, you kind of scrunch it in, going like that. So that's a compression. But horizontally, going this way now, starts off like this, and you're kind of stretching it out more like that. So horizontally, it's a stretch. So a horizontal stretch can be thought of as a vertical compression and vice versa. Okay? So I think of vertically, that's a stretch, but horizontally, it's a shrink or a compression. Okay. That's all that's going on here. Okay. What they have is correct. I advise you to just, on your formula cheat sheet, just put some of these examples down, and hopefully that'll be enough to kind of get you started with this. Okay. Page 175, they give you a lot of examples here. I'll just fly through a lot of them and see what's going on. 175. Okay, A. They replace f of x with f of negative x. Okay. And you see it's a reflection across the y-axis. Okay. The reflection of the blue is the red, and vice versa. Because the graph crosses, if you have a hard time seeing that, you can break it up into parts. Right? If you only look at that part, then you see, oh yeah, the blue and the red reflect across the y-axis. And then if you only look at that part, so oh yeah, the blue and the red reflect. So if you have a hard time seeing the whole thing, then just break it into pieces. B looks like a reflection across the x-axis. That's if you change f of x to negative f of x, letter B, f of x, negative f of x. Okay. Reflection across the x-axis. Okay, and let's see, C looks like the same thing. D. F parentheses x plus 1. That's 1 unit to the left. So the blue graph got moved 1 to the left. Okay. And let's see. I don't really want to show you these too much, but I want to show you this one. Yeah, here's an example of a compression. Here's the original function, f of x. Half f of x. So here's 2, right? Half of 4 is 2. Half of 1 is a half. So it's like you take the blue graph and you just compress it. You press down on it. So it gets compressed down to like that. Okay. All right. I don't really want to show you these others because it doesn't help that much in my opinion. But that shows you an example of that. Okay. Let me get started with some of these problems. What time is it? 12:25, so I think we're good. So sketch the graph, not by plotting points, but just start with a basic graph and you do stuff to it. Okay, so what are we supposed to do? 3 to 39 odd. Okay, I won't finish it today. That's okay. I have on schedule 3.4 and 3.5 tomorrow, so I'll just do some. So sketch the graph, start with the basic function and then go from there. Okay, so how about I'll do number 3. number 3, page 179. Y equals x cubed minus 3. Aha. Whoops. What happened there? All right, we're not plotting points. We're just taking the basic graph that we know and adjusting it. Okay, so what does x cubed look like? The cubic function? You should recognize this, or if not, put it on your cheat sheet. X cubed. Here's a key point, 0, 0, right? So what does that minus 3 do? 3 units down. Okay. And to highlight that, let's put 0, 0 becoming what point? 0, negative 3. Right? I should have changed colors, but anyway. Just draw the same basic graph. So that's the idea. So the translation, we would say, the translation is 3 units down. By the way, double check. What do you get when you plug in 0? -3. So you know you did it right. Okay. Now, if you put it above, so, wonder if it should go up or down, then you would have 0, 3. But when you plug in 0, you don't get 3, right? You get -3. So that's a little double check that if you plug in points, it should match. Okay. All right. How about 7? X minus 4 squared. Okay. So I take my basic x squared. Parentheses x minus 4. That will move me 4 units which way? 4 units to the right. So what does 0, 0 become if I move 4 units over? 4, 0. That's the kind of thing I want you to be able to do, to show me. It doesn't go to the left. You can check that. Take a look. What happens when I plug in 4? 4 minus 4? 0. 0 squared is 0. But if you put it over here, you would be at -4. But when you plug in -4, you don't get 0, right? So that's sort of a nice little double check that you can have for that. Okay, let's see. 9 should be a very easy one, I hope. -x squared. X squared. Oh, I should have written this down, sorry. Let me write this down for you quickly. 6 minus 4 squared. X squared. -x squared. Goes down. So it's a reflection across the x-axis, you say. Something like that. Okay. All right, do a few more, not that many more, but let's see, 13. Square root of x minus 3. So I start with my square root function, right? Square root looks like this. And be careful, it makes a big difference if the -3 is inside or outside. Okay? If it's outside, that moves the graph 3 units down. How about if it's inside? It still moves it 3 units, but which way? To the right. Double check. This is 0, 0. If I move 3 to the right, what would this point be? 3, 0. By the way, what do you get when you plug in 3? 0. Okay. But if you went this way, right? If you move 3 to the left, saying, I think I should move 3 to the left, you'd be at -3. But when you plug in -3, you don't get 0, right? In fact, it's not even defined. You have a square root of a negative. So that's that. Okay. Okay, let me give you some combination ones, a little bit harder. Yeah, 15 is much harder, actually. Pretty sneaky. square root of negative x plus 3. So how do I approach that one? There's a couple ways you can do it. Okay. So what am I going to do with that now? Okay. If I reflect across the y-axis, I get this, square root of negative x. What do we do with this now, though? And this gets a little bit tricky. We actually have to do a little bit of algebra here. Let me write this alternatively as if I factor out a negative 1, it looks like that. Okay, if I distribute this back, negative x minus a minus 3, it looks like so. Which means I know what to do with that. Square root of x minus 3, in fact, we just did that. Then the minus reflects across the y-axis. So what do I mean? I really want to go back to this picture in reality. So I'm kind of going up. I'm piggybacking off of what I did from 15, so to speak. Okay, that's what I have here. If I replace this with the opposite of it, negative in front of the whole thing, that's what I have here. Then I get the reflection across the y-axis, which means I end up going like this. It's pretty weird. So this is square root, whoops. Square root of negative parentheses x minus 3, which algebraically is the same as square root of negative x plus 3 like that. Okay, so that's what I want. It's definitely a much harder problem. Okay. All right, so that's that. So I should draw a line here. So 15 kind of went from here up to here to here. Okay. And let's see, what else do I want to show you? Show you 17 perhaps? I won't go much longer. I'll give you something to do. Y equals 1 over x plus 2 plus 2. Okay. That moves 2 to the left. That moves 2 up. Okay, so 1 over x, what does 1 over x look like? Over x, 1, 1, negative 1, negative 1. This goes 2 left. This goes 2 up. So how do I graph it? maybe I'll just take each of these points and get the corresponding points. Okay, so what happens if I move this 2 to the left and 2 up? 2 left, 2 up, that would be -3 and a +1, right? And how about this one? 2 left and 2 up, that would be -1, 3. Okay. So that point goes over there, that point goes over there. So what I'm going to try to do is the following. Now the asymptotes get moved also, these lines the graph gets close to. But in this case, it doesn't touch. So I'll go 2 to the left. So 2 to the left here would be actually equals -2. And the x-axis, which is y equals 0, ends up becoming y equals 2. Like that. Okay, so the y-axis, which used to be an asymptote, 2 left, x equals -2. X-axis, which used to be an asymptote, go up to y equals 2. Okay, then I'll just put these 2 key points and then draw the graph. So -3, 1. -3, 1 is like there. And I just curve it toward the asymptotes like that and like that. And -1, 3, -1, 1, 2, 3, curve it toward the asymptotes. So something like that. Okay, so that's what we have. All right, folks, I'm done for today. I was done with about half of what I was going to do for the second, and that's on par is what we were aiming for 3, 3, and about half of 3, 4. So I was able to do that. So I'll do more of 3.4 tomorrow. Okay, so in class right now, if you could take a picture on your cell phone, or it's right off the book, in essence. Okay. Now, it's part of problem 2. It's a matching exercise. Okay. There's a lot there. It goes from A through L. So little a to little l has a match from capital A to capital L. I only want you to do A, B, C, and D. Little a, little b, little c, little d. Okay. So if you want to take a picture on your cell phone, if you wish, or if you got the book, that's best. Okay, so just 2 little a, little b, little c, little d. But the possible answers are anything from capital A down to capital L. Okay, and I know the book's kind of heavy. So I'll tell you what, I'm going to hold it like this. So again, 2 A, B, C, D, little a, little b, little c, little d. When you're done, just type it in the chat and you're done, then you can go. So I'll hold this for maybe 15 seconds. You want little a, little b, little c, little d, but you also want capital A, B, C, D, E, F, G as potential answers. And I have to scroll down for a little bit more. Okay, so again, just do 2 little a, b, c, d. Okay, and now the ones after. So there's F, G, H. Okay, so how do you type it? Type little a and then a capital letter, little b and then a capital letter, little c and then a capital letter, little d and then a capital letter, and then you're done. Okay. So again, 2, I want you to just do little a, b, c, and d. The correct answer is one of the capital letters. They could be anything from capital A down to capital L. Okay, I'll go one more time, and then that's probably all I want to do. And then you're done for the day, then you can go. If you have a question, you can put it in the chat, okay? And Mackenzie or Star will be able to help perhaps. Okay, so once more, 2 little a, b, c, d, put a capital letter. The capital letter can be something from A through L. And that's it. Okay, so I'm going to make this disappear because the book is heavy. Hopefully you all get it. If you didn't, ask me and I'll go from there. Okay, and I will pause it. No more recording, so don't need